Hello students, today we are going to see the multiplications involved in scalar and vector. So there are four types of multiplication can take place. So first one will be the scalar and a scalar multiplication. This is the ordinary multiplication we do in the mathematics. 2 into 3 is 6, 2 into 6 12, both are scalar, only the magnitude is here. So if you multiply these two scalar quantities, we get an answer which is also a scalar quantity. So a scalar multiplied by a scalar will give you a scalar quantity. If you multiply a scalar with a vector, we get a vector quantity. And then if you multiply a vector and vector, there is a possibility also. In this combination, we can have either a dot product or cross product. If you take dot product, you get an answer as scalar. If you take cross product, you get an answer as vector. So in the first, let us see the first two things in detail. This one is ordinary mathematics. The second one, scalar and vector, it is something like this. You can see this in diagram. Here A is a vector. If you multiply with a scalar 2, now you get 2 times A. That means the A is multiplied 2 times A. So here this one is I vector. 2I means 2 times I. The length is increased by 2 times. So if you multiply a vector with a scalar quantity 2, definitely your answer is once again going to be a vector. So that's what it is given here. So here at some example J, so 2J. So the first instance what you are getting in scalar vector multiplication is definitely going to get a vector. And the second thing, the direction of this certain vector will be same of the quantity which is involved in the multiplication. So let us see these two things in very much in detail. Vector multiplication. So in this multiplication, if you take a dot product, the net answer will be a scalar. So this one, this dot product as well as cross product, we already have studied these things. Anyhow, we will refer and we will look into a little more detail. So here scalar A dot B is equal to AB cos theta. So both here A, B represents only the magnitude, no direction is involved. So A vector here, B vector here, theta is the angle between A and B. So if you project B vector on A, what you get, the projection of B on A, the length of this quantity up to this quantity will be B cos. How will you get this one? Cos theta is equal to adjacent by hypotenuse. So cos theta is equal to this quantity divided by B. So this quantity will be given by B into cos theta. That's what here. So if you multiply this here, this vector present in the axis, get A B cos theta. That's what you are getting here. So A B cos theta. If both the vectors are perpendicular, then theta will be 90 degree. In that case, if B is like this, if we is standing like a straight line, what will be? There will be no projection. So B cos theta naturally becomes 0 because B of cos 90 will become 0. So dot product will become 0. So for checking any perpendicular condition, we always go with the dot product. If both the vectors are identical, A dot A, then you get A square because the theta will be 0. So cos 0 will be 1, you get A into A, you get A square. Let us see the properties of this scalar product. So same vector means I dot I or J dot J, K dot K will be equal to 1. If it is other vectors I dot J or J dot K or K dot A or I dot K, whatever will be the combination, definitely going to be 0 because the angle between them will be 90 degrees. If you multiply these two vectors, say A vector, that is A has 3 components, X component, Y component and Z component. Likewise, B is also having here. So let us see the first quantity, AXI into BXI. So I dot I is coming, I dot I will be equal to 1, so you get AX dx. If you multiply the first term with the other two terms, BYJ, then I dot J is going to be 0. So you won't get in terms. So whenever you given two vectors, always you do dot product for like vectors alone. So here AY into BY. So A Z into B Z. So you get 3 terms. Again, once again, it is a commutative property. Whether you do A dot B or B dot D, both are going to be same. So it has also obeyed distributive law. Distributive law means 3 vectors will be in one. So A dot B plus C means either A dot B plus A dot C. B plus C you can add and then you can take dot product, or you take dot product with A, then dot product with C. After you add these two dot products, you get distributive. Here you see the C vector is the addition of A vector plus B vector. We are going to take the dot product and C dot C, then it is C square. Here A plus B dot A plus B means A dot A, you get A square, B dot B, you get B square. For here, for 2A, what you have to do? First thing, for B dot A, it is A dot B cos theta. Then for this one, BA, you get AB cos theta. If you add these two things, you get 2AB cos theta. And fifth is an important property because here U dot B into W vector not be equal to U vector of B dot W. Here you can see here when you take dot product between U and V, you get a scalar quantity. This scalar is multiplied with vector, then your answer will be a vector quantity. Definitely, this is not the you multiply a scalar into vector, you get a vector quantity. Now the direction will be along the W vector. For here, B dot W is once again a scalar quantity, but when it is multiplied with the U vector, now the answer will be along the U vector. Completely entirely different vectors there. So when you do a scalar product, you have to look very careful along the parenthesis. If you want to find the angle between two vectors, no problem. You can find easily by cos theta is equal to AB by A dot B equal to AB. So here is an example. For A vector, you have taken 3, 1, 5, 3 AX I vector plus J vector plus 5K vector, and B vector 2I plus J plus 3K. Cos theta A dot B. So we had AX into BX, 3 into 2, 6 plus AY into BY, 1 into 1, 1, 5 into 3, 15, divided by magnitude of A will be 3 square plus 1 square plus 5 square plus magnitude of B square root of 4 plus 1 plus 9. We get 0.994. So cos theta 0.994 means theta is equal to cos inverse of 0.994. You get 6.3. For example, for some scalar product of work done on a body by a force through a distance dx. So work done will be equal to F into distance. So small work done dw equal to F dot dx. So only the component of force parallel to displacement does work. If the displacement is perpendicular to F, then you get the answer as 0 because answer will be F dx cos theta, cos 90 will become 0. So always the parallel component will be accounted for the work. Let us see the cross product. Here also two vectors are involved, and this will be a cross product. So A cross B equal to AB sin theta and n cap. The n cap means if this vector direction is perpendicular to A as well as perpendicular to B. That's what is given here. See, you can see A vector, B vector. This n vector will be perpendicular to A as well as to B. So if you want to find the direction still more using the right hand rule, take a right hand and see, you can see in this diagram, the thumb, take a right hand, thumb and first finger and with middle finger, position perpendicular to both each. See, this thumb is perpendicular to this index finger, this index finger is perpendicular to this middle finger, and once again thumb is perpendicular to middle finger. You have to point in such a way. So angle is 90 degrees, here also 90 degrees, and here also 90 degrees. So now point your thumb along the A vector direction, point the second finger along the B vector direction, and C direction will be perpendicular, will be the resultant. So that's what I said. The n vector is always perpendicular to A as well as for B. This is the properties of vector product. A plus B cross C. You can do A cross C plus B cross C. A cross B will not be equal to B cross A. It is non-commutative. So it will be minus of B cross A. And here also we cannot, since it's non-commutative, it does not obey associative also. A cross B cross C, we cannot change the brackets. If M is a scalar, then it's quite easy. M into A cross B means either you can multiply M with A or M with any one should do. MA cross B you can write, or A cross M. You should not write MA into M. That's what is very important. And if A cross B is 0, we can say the vectors are parallel, because we know A cross B equal AB sin theta. If it is parallel, sin 0, theta will be 0, sin 0 will become 0. So to check any parallel condition, we have to take A cross B, and A cross A equal to 0. That means I cross I or J cross J, K cross K will always equal to 0. And one another thing, I cross J will be equal to K, because K will be perpendicular to I and J. So J cross K will be equal to I. Likewise, you can do it. If you easily by finding the cross product, it will be very easy to use this determinant form I, J, K. The second row will be A vector components, and third row will be the B vector. You should not change the rows. So then you can expand this determination to find out the answer. So this is what I say, I J, K, J cross K will be I, K cross I will be J. If there is any J cross I, then you have to write it as minus K. K cross J minus I cross K minus J. That is more important. Here you can see identical vectors will be 0. So I cross I, J cross I will be 0. So always avoid AX, BX. Okay. So you can do very easy. Some example for this is torque, angular momentum, and Lorentz force. The torque is given by torque is equal to R cross F, and the torque vector is perpendicular to both R vector and force. F is the force, R is the radial distance. So torque will be given RF sin theta. Momentum will be given by R into P, and here momentum, P is called momentum, R is the position. At which position we are calculating the angular momentum. The net value will be RP sin theta. So this angular momentum will be 90 degrees to both R and P. The another one will be Lorentz force equation. This is the force experienced by in a magnetic field by a charged particle. The charge is moving in a magnetic field. The force experienced by the Q will be equal to Q into V cross P. We derived this derivation in detail in unit 3. So F equal to QV into QV cross B. This is the best example for the cross product in EMF. There are two triple product. One is scalar triple product and another one is vector triple product. A dot B cross C. So this will be in order A, B, C, B, C, A, C, A, B. But the first one is a dot and second is a cross. So this cross product will give a vector. This vector is dotted with another vector which is scalar. So this one can be easily done by the determinant form. First one will be A vector, another one will be the B vector row, and third one will be the C vector row. So you can easily expand this determination to find out the scalar to be. You should not change the order. A, B, C, first one dot product, and second one will be the cross product. For cross product alone, we have to insert the parenthesis because it has to be done first. In vector triple product, all the will be cross product only A, B, C. So A cross B cross C, and you should not change the parenthesis. A cross B cross C, so it will be no longer equal to not. So if you want to do A cross B cross C, you cannot solve like this determinant form. You have to use back cap. So BAC minus CAB. Can you easily remember using this one? Back cap. Just crossing this one, you have one determinant. Then A cross this thing, another 2 times you have to do. But this one will be quite easy because dot product is very easy compared to the cross product. BAC minus CAB. So here dot product, it is a vector. So scalar vector multiplication like this you can do easily. So I think you have understand very well the vector multiplication. So let us see the different types of coordinate system in the next class. If you have any doubt, you can mail me or message me. Thank you. Have a nice day.